So we've been discussing congruent triangles for the past few days now. We've looked at proofs of congruent triangles, and we even looked at what happens after you prove congruent triangles, that you can go on to talking about the parts of congruent triangles. But not every proof has to end there, okay? If we're proving congruent triangles, it's probably going to end with this. If we're proving a part of congruent triangle, it's probably going to end with that. But we could continue to prove other things. So we want to discuss some of those other things that we could be asked to prove or that could show up in a proof. A median, for example. A median is a segment from a vertex of a triangle to the midpoint of the opposite side. Okay? In other words, if I were to draw a triangle, let's draw a little triangle over here, and put a midpoint on here. So there's a midpoint of that side. The median would be this segment here that connects from a vertex to the midpoint of that opposite side. That's a median. An altitude is different. An altitude is a segment from the vertex of a triangle perpendicular to the opposite side. So in other words, if I drew a triangle, we'll draw a different triangle this time. There we go. And I put in a segment that goes from here down there and makes a right angle. That's the big thing. So this time we're not necessarily hitting a midpoint. This one's not necessarily perpendicular. That one's not necessarily hitting a midpoint. The two of those together, well, that's different. So an altitude makes a right angle. A median hits a midpoint. Now, let's put the two of those together. Perpendicular bisector. This does two things. A perpendicular bisector is a segment perpendicular to another, I can't spell, A-N-O-T-A, another segment at the midpoint. Okay, so when we're talking about, hey, let's draw in a random segment here, a perpendicular bisector, I'll draw it in green, we'll do two things. It's going to hit at a midpoint, so these two parts are congruent, and make a right angle. So that does two different things. We've already talked about perpendiculars. We've talked about segment bisectors. So when something does both of those, it's a perpendicular bisector. So that's a lot of information. Okay, isosceles triangle. We already know what an isosceles triangle is. Okay, a triangle with two congruent sides. But it also has more. The base angles of an isosceles triangle are congruent. This is a theorem about isosceles triangles. Okay, that if I have a triangle that is isosceles, so these two sides are congruent, then the base angles, this angle and that angle, will also be congruent. Okay, we can also use that. If I know the base angles are congruent, then it must be isosceles triangle. So it's what's called a biconditional. And in parallel lines, we already know about if parallel lines are cut by a transversal, then a bunch of things happen. Okay, we could say alternate interior angles are congruent or exterior. We could say corresponding angles are congruent. We could say same side interior. Are supplementary. I'll just abbreviate supplementary. Well, if I need to prove parallel lines, I can actually prove parallel lines using any of these. If we have corresponding angles congruent, then lines cut by transversal are parallel lines. Okay, if I have alternate exterior angles congruent, then lines cut by transversal are parallel. So it would look something like this. If I knew this angle is congruent to that angle, so this is my given, then I know if alternate interior angles are congruent, then I can conclude lines cut by a transversal are parallel. Okay, so it's a way that we can prove whether lines are parallel or not. So let's look at an example of going beyond CPCTC. Okay, this is a quick, easy example. And we're going to take a quick look at this. Okay.